Good morning, children. Today I am sending two videos. One is your revision video for 13 minutes, 12 minutes, and other video is regular class, that is chemical bonding. This topic is little bit deleted, amma. So why to leave that? Just and touching all the concepts which are useful in your further education. Chemical bonding, they are saying it is deleted from the 10th portion. So till now we completed 9 lessons. From that 8th lesson are left, that chemical bonding. It is not there in for your essay 1, but is useful for your further studies. So what is ionic bond? The bond formed by the transfer of electrons from one element to the other element is said to be a ionic bond. And in ionic bond, the bond formed between two ions also, that is cation and anions. What is a cation? By losing the electron, it acquires a positive charge and they are said to be a cations. By gaining the electrons, it gets a negative charge and they are said to be a anions. And the bond formed between the two ions is said to be a ionic bond. It is also known as a electrovalent bond. Why they will participate in a bond formation? To get a stable configuration. When you will get the stability? If they have the 8 electrons in the outermost shell. To get that 8 electrons, they will participate in a chemical bond. And we discussed about Lewis dot structure also, representing 8 outermost electrons around the element in the form of a dot or a cross is said to be a Lewis dot structure. Next, methane. Formula is CH4. CH4 molecule. In that carbon, it consisting of a 4 singly occupied electrons, and hydrogen 4 are hydrogens with a 1 unpaired electrons combines with a carbon and shares the electrons. By sharing the electron, if a bond is formed, then such bond is said to be a covalent bond. You can see the good example is a methane. Carbon atomic number is 6, its configuration is 1s2, 2s2, 2p4, 2. So 2 unpaired electrons and 2 paired electrons of this will participate in a bond formation, and to share that 4 carbons will participate. 4 electrons of 4 hydrogens will combine with the 4 electrons of carbon and they share the electron. If we check around the carbon, 4 hydrogens contributing 1 electron and carbon is contributing 4 electrons. So total 8 electrons around the carbon. By sharing, they are getting the octet state configuration. Next example, ammonia. Nitrogen, 3 unpaired electrons. So 3 unpaired electrons are combined with 3 hydrogens and forms as a bond. So it is said to be a covalent bond. And another example is water. In water, oxygen, 2 unpaired electrons and 2 paired electrons. This combines with the 2 hydrogens and form the bond and is said to be a water molecule. Here also in ammonia, methane and water, the bond is formed by sharing of electrons. So it is said to be a covalent bond. And the bond energies and bond length and bond energies. So bond length or bond distance is a equilibrium distance between the nuclei of 2 atoms which form a covalent bond. You can see the oxygen and hydrogen. The distance between the equivalent distance between 2 atoms is said to be a bond length or bond distance. It is measured in angstroms. Measured in angstroms. Okay. And now comes to the drawbacks of a electron theory of valency. When covalent bond is formed between any 2 atoms, irrespective of nature of atoms, the bond length and the bond energy is expected to be same. But after the bond formation, the bond energies and bond lengths are different. If you are making chapati with a jawar, you will get a jawar taste. If you make a chapati with a wheat, you will get a sweetened taste. But here, the bond lengths of individual atoms are different. After the combination, bond lengths and bond energies are different. Why that change? That is one drawback and could not explained by valence theory. So now valence shell electron pair repulsion theory help us to understand the bond lengths and bond energies. Let us discuss. VSEP RT valence and electron pair repulsion theory. Consider the electrons in the valence shell which are in covalent bonds and in a lone pairs as a charged clouds. They repel one another and stay far away. This is the reason why molecules get specific shapes. First point, in covalent bonds, here we can see the lone pair and a bonded pair. Lone pair means which does not participate in a bond is said to be a lone pair. Already it is a bonded. So the repulsion between two lone pairs will make us to give a particular shape. Next, if we know the total number of electron pairs in the valence shell as a covalent bonds and lone pairs in central atom, it helps us to predict the arrangement of those pairs around the nucleus of central atom and that of the shape of the molecules. If we know the information from what are the lone pairs, what are the bonded pairs around the central atom, then easily we can guess the shape and its nucleus on the central atom. Okay, next. Lone pair occupy most pairs around the central atom than the bond pairs. Lone pair means unshaded electron pair, non-bonding electron pair. Already it is paired. That pair is said to be lone pair, two electrons. But in the case of carbon, let me show that. Carbon atomic number is 6. Its configuration is 1s2, 2s2 and 2p, 2ma. In this 2s it is paired. Outermost or not? This is outermost. In this 2 unpaired. Means 2 paired and 2 unpaired. And these 2 paired electrons never participates in a bond formation. That's why they are said to be lone pair. And these 2 unpaired electrons will try to participate in a bond formation to get a octet and a pair. So it is said to be a bonded pair. Lone pair, bonded pair. Clear? Lone pair means unshaded pair. Bonded pair means which ready to share the electron. So the shape of the element depends upon its bonded pair and a lone pair. The repulsion and attraction between the bonded pair and lone pair will help us to find the bond energies, bond length and decide the shape. If 2 bond pairs are present in 2 covalent bonds around the nucleus of central atom without lone pair in the valence shell, they are separated by 180 and minimum repulsion and the molecule would be linear. What is saying? 2 bonded pairs means 2 unpaired electrons if they are present. They can bond with others. So they are said to be bonded pair. And in that bonded pair, if they are the 2 bonded pairs without lone pair, then what will be the shape of that? Linear. What would be the angle between 2 atoms? 180 degrees. Remember. Once again, if 2 bond pairs are present without any lone pair, cleared about bond pair ma? The 2 electrons, 1s2, 2s2, 2 are there. Means already paired, never participate in a bond formation. Such are said to be a lone pair. If 2 bond pairs and without any lone pair is present, if it is present in them, then what would be the angle for them? 180 degrees. What is the shape? Linear. If 3 bond pairs and without any lone pair, then what would be the shape of that? Trigonal planar. Trigonal planar shape. And what would be the angle? 120. 3 bond pairs are present without any lone pair, then they are separated by 120 degrees and the bond pair shape of that is trigonal planar. Next, Did you notice BCCl2 and BF3 on the central atom? Beryllium and boron did not possess 8 electrons. Around the nucleus, they have only 4 and 6 respectively. These molecules are known as electron deficient molecules. Let me check. In the case of boron, if you check boron, how many are there? Around the boron, 6. And in the case of a beryllium, we will have only 2. So 4 and 6 they have that. So 4 and 6 electrons, not 8. And that molecules are known as electron deficient molecules. What is meant by electron deficient molecules? In the outermost shell, if they possess 4 or 6 electrons, not 8, such molecules are said to be electron deficient molecules. And if they are the 4 bonds in the valence shell without any lone pairs, then the angle will be the tetrahedron and shape will be the tetrahedron. Angle is 109 degrees 28 inches. How I am reading? 109 degrees 28 inches. Example, methane. Methane formula CH4. CH4. And how they will write? Hydrogen, carbon, angle, hydrogen. And how many? What is the angle? 109 degrees 28 inches. What could be their shape? Tetrahedron. If there are 3 bond pairs and 1 lone pair, then it is said to be a ammonia molecules and around the occupies it more space. Among that it occupies the more space. So in ammonia there are 3 bond pairs in covalent bonds around the nucleus of nitrogen and 1 lone pair on the nitrogen. So the bond pair and lone pair repulsion is greater. Due to that, bond angle is decreased to 107 degrees and 48 inches. Maybe there is a slight change in the shape also. And next, if there are 2 bond pairs and 2 lone pairs, therefore angle between bond pair further decreases and you will get the angle of 104 degrees and 31 inches. What is the bond angle in a molecule? If it is angle suspended to imaginary lines that passes from nuclei of 2 atoms. Is it? Valence shell electron pair repulsion theory mainly fail in explaining the strength of bonds. This is because the theory still depends upon Lewis concept. He could not say anything extra about the electron nature of a bond. And this theory, valence shell electron pair repulsion theory also failed because it is like a Lewis dot structure only. So he could not say any extra. So his theory also failed. To understand that valence bond theory suggested by Linus Pauling, and he said that due to the 2 bond pair and lone pairs, then we will get the different shapes. So already informed, this lesson is deleted from your portion mark. So just I am not going deep into that. Whatever the topics most important, I am repeating. Okay, from the chemical bond. And today I am sending 2 videos. One is revision video for 15 minutes, 12-30 minutes. And this video is for 12 to 13 minutes. Don't want to make a lengthy videos, so I may shortcut into 12 to 13 minutes video. Please watch, cover the revision as well as the lessons also. You watch that. Okay, thank you children.